What if we had a double-sized moon? Have you ever looked up at the moon and wondered, what if it were twice its current size? Not just in appearance, but in actual diameter? What kind of chain reaction would it set off on Earth, our tides, our climate, and even life itself? Let's explore an alternate universe, where the moon is double the size it is now, and what we find may surprise you. Let's get the science right first. If the moon were twice its current diameter, it wouldn't just be bigger, it would be dramatically heavier. Since volume increases with the cube of the radius, doubling the moon's size would make its mass around 8 times greater. That means the moon's gravitational pull on Earth would increase significantly, and this would lead to some major changes here at home. Our moon currently causes tides by pulling on Earth's oceans. With 8 times the mass, the gravitational force would be much stronger. Tides would be massively amplified. Imagine coastal cities like New York or Tokyo dealing with tides several meters higher than today. Flooding would be a regular event, not a rare occurrence. Some areas might become permanently submerged. Coastal development would have to shift far inland. Ecosystems in tidal zones, like mangroves, estuaries, and salt marshes, would either adapt quickly or face collapse. Not only that, the increased erosion caused by more extreme tides could reshape coastlines permanently. Fishing industries might be disrupted, with changes in fish migration patterns and breeding cycles. The rhythm of life in the oceans would be thrown off balance. One of the more beautiful changes would be the moon's appearance in our sky. A double-sized moon would take up 4 times the area in the night sky. That means full moons would be far more stunning, brighter, and would light up the night almost like a weak streetlight. Shadows would be sharper. Nightscapes would be transformed. The moon would dominate the sky, visible even in twilight. Stargazing would become much harder due to the bright night sky. And nocturnal animals that rely on darkness? They might find it harder to hunt, mate, or hide. Certain species of insects, birds, and mammals that evolved under natural lunar cycles might struggle with the new brightness. Here's something you might not expect. Our days would be shorter, at least at first. So a larger moon would increase the tidal friction between Earth and the oceans. That friction slows Earth's rotation over time. With more tidal drag, Earth would spin down even faster. Right now, the moon is slowly pushing away from us, about 3.8 centimeters per year, causing Earth's rotation to slow down by 1.7 milliseconds per century. But with a larger moon, this process would be accelerated. Days would grow longer at a faster pace, and over millions of years, the Earth-Moon system would reach gravitational equilibrium sooner. That means in the distant future, we might see a tidally locked Earth, where one side always faces the moon, just as the moon now always shows us one face. That could affect wind patterns, ocean currents, and possibly even climate zones. Some scientists believe the moon helps stabilize Earth's tilt, the axial tilt that gives us seasons. A heavier moon might stabilize Earth's tilt even more, reducing how much the tilt changes over time. It sounds like good news. Fewer dramatic climate shifts due to wobbling, but it could also lock Earth into a more rigid climate pattern, possibly disrupting long-term cycles like the ice ages. On the other hand, some models suggest a heavier moon might actually make Earth's wobble worse, leading to unpredictable climate changes over time. The truth? We're not entirely sure. It depends on the complex interactions between the moon, Earth, and the sun over millions of years. The moon's gravitational docility just affects tides in the ocean. It also slightly deforms the Earth's crust. A larger moon would increase this gravitational flexing, especially around tectonic plate boundaries. The result? It's potentially more frequent or intense earthquakes and volcanic eruptions. Our planet's geology might become more active. Volcanoes might erupt more often. Earthquakes could be stronger, especially near coasts, where the lunar pull is most powerful. Let's think long-term. If Earth had always had a larger moon, life might have evolved very differently. The increased tides could have created larger and more dynamic tidal pools, which some scientists believe were essential to the origin of life. More extreme conditions might have accelerated evolution, but the downside? Stronger tides might also mean more frequent coastal extinctions, washing away early life forms before they could thrive. Marine life that depends on predictable tides might struggle. Animals that use the moon to navigate, like sea turtles or birds, might adapt or vanish altogether. The moon's bigger size would make lunar eclipses more dramatic. But more importantly, it would change our space exploration history. A larger moon would have greater gravity, about 2.8 times higher than the current moon. That means lunar landings would be more difficult. Rockets would need more fuel, and lunar missions might have been delayed, or even impossible with 20th century technology. Human colonization of the moon would be a bigger challenge. But with more mass, the moon could potentially retain a thin atmosphere, possibly opening the door to different types of colonization in the far future. A larger moon might also have stronger internal heat and tectonic activity. Could that mean ancient volcanism on the moon lasted longer? Or even the presence of underground water? These are exciting questions for future explorers. Human culture is full of references to the moon, in myths, poetry, music, and religion. A larger, brighter moon would have likely played an even bigger role in ancient civilizations. It might have been worshipped more widely, considered even more divine. Calendars could have been more closely tied to its phases. Folklore about werewolves, madness, and moon gods might have become more prominent, or taken very different forms. Ancient structures like Stonehenge or the pyramids might have been aligned to a more dominant moon. Let's not forget the moon acts as a shield for Earth. Its gravity captures or deflects asteroids that might otherwise strike us. A bigger moon would be even better at this. Earth might have suffered fewer major asteroid impacts, potentially preventing some mass extinctions. But here's the twist. A larger moon could also pull more debris toward Earth-Moon system. The net effect could go either way. Some regions might face increased meteor showers or more frequent small impacts. To an alien observer, Earth, with a massive, shining moon, would look even more unique. The moon would cast a larger shadow during solar eclipses, making them more spectacular and more frequent. From space, Earth might even be more visible, shining in tandem with its oversized satellite. It would be a cosmic dance, more dramatic and beautiful than what we see now. So, what if we had a double-sized moon? We'd have higher tides, brighter nights, more tectonic activity, and possibly faster climate changes. Our ecosystems, our weather, our myths, even our evolution would all be touched by its presence. It's a reminder that even a small change in the universe, like the size of our moon, could dramatically alter life as we know it. Our moon may seem quiet and distant, but its influence runs deeper than we often realize. What do you think? Do you want to live on a planet with a giant moon lighting up the night sky? Drop your thoughts in the comments. Don't forget to like this video if you enjoyed the journey, and subscribe for more what-if explorations that bend the boundaries of science and imagination. Thanks for watching, and see you in the next video.